Welcome to the deep dive. Today, we're peeling back the layers on something absolutely fundamental to our online world, but often totally unseen. We're talking Amazon Web Services, AWS, and specifically the incredible global network that makes it all tick. Our goal really is to figure out how AWS works as this giant virtual computer center, or maybe like a massive digital nervous system. Businesses, developers, anyone really can tap into it. And they just pay for what they use without needing any of their own physical gear. Imagine not needing to buy servers or deal with cooling, even if you suddenly get millions of users. That's the power we want to unpack.
Absolutely. And it's fascinating how much this hidden infrastructure really shapes our everyday digital experiences. The quiet engine, making sure your Netflix streams smoothly, your games don't lag, that critical app just works wherever you are. This deep dive is about more than just the tech specs. It's appreciating the sheer engineering that makes the internet so fast and reliable for all of us.
Okay, so we hear the cloud, we hear AWS, but it can still feel a bit nebulous. What really is AWS at its heart? What makes it such a big deal?
Well, it's less about just the services themselves, compute, storage, databases, all that, and more about the whole model. It turned everything on its head. Before AWS, if you wanted to build something online, you needed serious upfront cash for hardware, servers, racks, networking. AWS just democratized all that.
Yeah.
Suddenly, powerful tech wasn't just for the big players.
Mm.
So if you look at the big picture, it really comes down to, I'd say, three things. It's incredibly cost-effective, it's super flexible, and it scales like, well, almost infinitely. For a startup, this is huge. They can use the same kind of power as a massive corporation, paying pennies to start. No need for huge investment rounds just for servers. And for the big companies, they can ditch a lot of the operational headaches and costs, stop worrying about managing hardware and just focus on building cool stuff.
Right. That makes a lot of sense. So, this pay as you go, super flexible model is the game changer. But why the global infrastructure? Why spread out all over the world with data centers and network points? Couldn't they just build a few enormous ones?
That's a really good question. And honestly, that's where you see the strategic genius of AWS. This global footprint isn't just nice to have, it's absolutely core to what they offer. First off, speed. Physics matters, right? The closer the data is to you, the faster it gets to you. Less distance, less delay, lower latency. Then there's reliability. Downtime is incredibly expensive. So having multiple locations physically separate means if one data center has a problem, power outage, flood, whatever, others can take over. Your stuff stays online. Third, global reach, and importantly, compliance. Businesses need to serve customers everywhere, but they also have to follow local data laws. Think GDPR in Europe. AWS lets them do that easily by choosing where their data lives. And finally, scalability. And I mean massive scalability. Instantly going from handling a tiny blog to, say, millions of people hitting a site all at once during a sale or event. Think about Netflix again. When a new season drops, millions of people might start streaming simultaneously. They scale up instantly using AWS. And that video, it's likely coming from an AWS Edge location super close to you, just milliseconds away.
It's not just about your movie starting faster. It's about Netflix never having to physically build enough servers for that peak moment. Imagine trying to do that yourself. It's almost unthinkable, financially and technically.
Wow, yeah, that really puts it in perspective. Okay, so how does this global magic actually work architecturally? You mentioned it's not just one giant center, it's regions, availability zones, edge locations. How do those fit together?
Exactly. That's the core of their distributed design. Let's break them down. Think of it like zooming in, hashtag tag, tag, tag one regions.
All right, let's start with regions. These sound like the biggest pieces on the map. What are they, simply put, and why does it matter that they're separate?
Okay, think of an AWS region as like a distinct geographic area on the globe. US East and North Virginia, EU and Frankfurt, Asia Pacific and Tokyo, places like that. Each region is designed to be completely isolated from the others. Services, data, operations, they don't automatically cross region boundaries unless you specifically set that up. That isolation is key. It's for fault tolerance. If something catastrophic happens in one region, it doesn't affect the others. And it's crucial for compliance too. So when you choose a region, you're thinking about a few things. Where are my users? Closer means faster. What are the local data laws? Got to comply with those like GDPR. Sometimes cost varies a bit between regions too, so it's a strategic decision. As of now, I think there are over 30 regions worldwide, something like that. So yeah, a company targeting European customers might choose the Frankfurt or Dublin region to keep data local and performance snappy for those users. Hashtag tag, hashtag two, availability zones, AZs.
Okay, so regions give you that geographic separation and strategic placement. But what about within a region? You wouldn't want one power outage or fire taking down the whole thing, right? That's where availability zones come in, I assume.
Exactly right. You've nailed their purpose. Availability zones, or AZs, are the next level down. An AZ is basically one or more discrete data centers within a single region. The clever part: each AZ has its own independent power, cooling, and networking. They're physically separate buildings, often miles apart, but crucially, they're close enough to have really fast, low-latency network connections between them within the same region. So this physical separation is what gives you high availability and fault tolerance. If one AZ gets hit by something, a power failure, a network issue, maybe even a localized flood, your applications running in other AZs in that same region just keep chugging along. It means you can architect your applications to be resilient. You spread them across multiple AZs. Maybe your main database is in AZ1, a replica is in AZ2, and your web servers are spread across both. No single point of failure. Most regions have typically 3 or more AZs, usually between 3 and 6. Think of it like separate, secure buildings within the same city campus, each with its own utilities but connected by high-speed links. A bank, for example, would absolutely run its critical systems across multiple AZs in a region like London or New York. One AZ issue won't stop trading. Hashtag 3. Edge locations.
Right, regions for geography, AZs for resilience within a region. And then there are edge locations. These sound like they're pushed out even further, closer to the actual users. What's their job?
Exactly. Edge locations are all about that final stretch, getting content to the user as fast as humanly, well, technically possible. They're much smaller AWS sites compared to the data centers and AZs, but there are way more of them. We're talking hundreds globally, I think over 400 now. Their main job is caching. They temporarily store copies of frequently accessed content, things like images, videos, website-style sheets, JavaScript files. They work hand in hand with services like Amazon CloudFront, which is AWS's CDN, or Content Delivery Network. So when you request, say, a video or a product image, CloudFront figures out the closest edge location to you that has a copy of that file cached. It serves it directly from there, super fast, instead of having to go all the way back to the main region where the original file lives. This makes a huge difference in how fast websites load and videos stream. But they do more than just caching. They're also used for security services like AWS Shield to help fight off DDoS attacks, and for DNS lookups with Route 53. They're like these little versatile outposts. Analogy time. Think of them like local mini warehouses or distribution points for an online store. Instead of shipping everything from one central mega warehouse, they keep the popular stuff stocked nearby in your city, so delivery is almost instant. That's streaming service caching movies. They're using edge locations in cities all over the world so your movie starts playing instantly.
Okay, wow. So putting it all together then, regions, AZs, edge locations, how does this whole system work in concert? It sounds like this really intricate dance to give us that seamless experience.
It really is. It's a beautifully coordinated system, and that synergy is the magic of AWS infrastructure. So regions give you the big geographic zones. You pick them based on where your users are, data laws, maybe cost, strategic placement. Then, within your chosen region, the availability zones give you the muscle, the resilience. Spreading your app across multiple AZs means it stays up. Even if one data center has a bad day, that's your high availability. And finally, the edge locations act like accelerators. They take the content your users access most often and push it right to their doorstep, digitally speaking. That's your speed and responsiveness. Let's take that e-commerce company again, launching a new product globally. They might choose, say, the U.S. East region in North Virginia for their main website and backend databases, maybe because a lot of their team or initial customers are there. But for the launch, they absolutely need it to stay online. So they'll run their web servers across at least 2, probably 3 different availability zones within that U.S. East region. Resilience.check. Then to make sure products, photos, and promo videos load instantly for customers in London, Sydney, Sao Paulo.
Everywhere they use CloudFront. CloudFront automatically caches those images and videos in edge locations all around the world. Speed, check. So you see, the region provides the home base and compliance anchor. The EZs provide the uptime and disaster recovery within that home base. And the edge locations provide the global speed for content delivery. It all works together. Fast, reliable, global, and compliant.
That paints a really clear picture. It's quite the system. Understanding that structure really shows how AWS manages to power so much of the internet. It makes incredibly powerful technology available, reliable, and efficient for basically everyone, from a single developer tinkering on a project to, the biggest companies on the planet. It really is a marvel.
It really is. And it makes you think, doesn't it? In this world where we just expect everything to be instantly available, globally connected,
Yeah.
how does this invisible infrastructure, this ability to essentially rent world-class tech instead of buying and managing mountains of hardware, How does that fundamentally change the game? What does it mean for innovation when a tiny startup can leverage the same backbone as a tech giant? It really levels the playing field in some profound ways.
That's a great question to ponder. The next time you're streaming, shopping, or using almost any app, just take a second to think about that unseen network humming away beneath it all. It's making everything faster and more reliable. Thanks for joining us on this deep dive. We'll catch you on the next one.